Good morning. Morning coffee time. Like I said, I'm actually cooking dinner. But so, what is gravity? Um, you could say it's a diluted form of magnetism, but it isn't really doing it justice as to what it is. So the electromagnetic field that everybody treats as two different things. I don't know why. It's one thing. It's one field. It's the only field we've ever studied, ever detected, ever done anything with. Everything we've ever done is the electromagnetic field. Once you study the electromagnetic field and understand what it is and what it encompasses, where it goes, it's everywhere. It's in different gradients. It has to be in different gradients by its own definition. So what is it? This is my mass. This is my particle. It's super tiny, but it's here. And it's almost weightless because it's almost non-existent. But because it exists, even an Einstein has this, because it exists, reality, the electromagnetic field, warps around it. And this is a tension in the grid. It's not supposed to be there. It creates a tension. Okay, maybe it is supposed to be, I don't know. Whatever the case, because it's there, there's a tension. And as it moves or as it spins, one or the other, let's go with spinning. As it spins, it grabs that field and causes more tension. It tightens on it harder. It's like grabbing a rope and just cranking on it. But the rope resists and cranks back. So we get this push and this pull, like this, right? We call it positive and negative. We call it electrons and protons and all this other stuff. And the end result is it's the particle, its existence, and its interaction with the electromagnetic field. What we've been studying for 120 years, called the electron, is actually the magnetic field that goes around, shelters, protects, closes it off. Right? And in doing so, it creates a magnetic field. And that magnetic field, as this tension spins, it creates a tightening effect on that field. We measure that. It's the same field. Electricity and magnetism is exactly the same thing. We just measure it in two different directions. When we look at it on an electric wire, we have a positive and a negative. There's no positive and negative. Okay, but we look at it that way. There's a positive and a negative. We say there's a source and a ground. Okay, but what it is one field. And we're looking at the tension. So we measure it down in voltage. All right? But it's tension. That same tension, Einstein explains, is space-time warps around matter and squashes everybody to the planet. He doesn't really explain how or why, but he's got that much figured out. Along comes Maxwell and Lorentz trying to, Lorentz is trying to work on what Maxwell had. And he's explaining a lot of this stuff to Einstein, who already figured out a lot of it in school, but a lot of it doesn't make sense because he's using space-time. Lorentz is using or looking for the ether, right? He's looking for a fluid or a wind, and but he's measuring magnetism. He knows it's magnetism. He's looking at magnetism, but he thinks magnetism is created by a wind or a fluid. And if you start studying magnetism when you first do it, it really looks like that. It really does. But here was the thing that turned me off from the whole fluid concept of it all. Well, first of all, I already left fluid gravity before that. But the real kicker is I could take a magnet, powerful, strong magnet. I could see its field. I could see how big that magnet is. And as long as it ain't grabbing onto any metallic magnetic force, as long as it ain't grabbing onto something, I know where the magnetic field is. And if, according to the fluid gravity, magnetism, that means that there is a fluid that's making this magnet work, which means it has grip to that fluid. And I can move that like there was nothing there. Nothing at all. At all. Almost like it was a field rather than a fluid.